Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And with us today is an astronomer who'll talk to us about the eclipse of the century. If you miss it, well, you may have to wait a few more decades for the next one. Yes, it was 40 years ago. 40 years ago in the United States that the people here had a chance to witness a total eclipse that crossed the continental United States. On August 21st, write that date down on your calendar. August 21st, you may have the opportunity to see a total eclipse of the sun. In fact, there are maps showing exactly where the shadow is going to cut across the continental United States. And even if you can't take a car ride or a plane ride to this narrow strip where you'll see the total eclipse of the sun, everybody will see a partial eclipse of the sun. But then the question is, how do you do it? You have to be careful because according to legend, Galileo himself burned his retina looking at the sun. In fact, according to legend, he eventually went blind in one eye. So the question is, how do you look at the sun? And just remember that solar eclipses are not forever. Millions of years from now, the moon is leaving us at the rate of about an inch a year, and it means that millions of years from now, we will not have a perfect coincidence when the moon and the sun apparently have the same size as seen from the planet Earth. So with us today is Professor Andrew Fracknoy, author of a children's book, When the Sun Goes Dark, and he's also convinced the Moore Foundation and Google to donate 2 million special eclipse glasses for free at local public libraries, because we don't want people to injure themselves looking at the eclipse of the century. Now, fortunately, if you missed this one, there's another one in 2024. That's quite rare. You have 2 opportunities to see a total eclipse of the sun. I remember seeing a partial eclipse of the sun right here in Manhattan, where I am right now. I got a pinhole camera. That is, I got an ordinary sheet of paper, pricked it with a pinhole, and put a second sheet of paper beneath it, and lo and behold, you could see the image, a pinhole image of the sun as it was being partially eclipsed by the moon. And once again, the difference between a solar eclipse and a lunar eclipse is as follows. A lunar eclipse is when the moon falls into the shadow of the Earth. They happen rather frequently, once every few months. A solar eclipse, especially a total solar eclipse, is extremely rare. Like I said, the last time was 40 years ago, and you'll have a chance to see this on August 21st. And already the networks, all the big TV shows, everyone's talking about having specials around the eclipse of August 21st, when the moon goes right in front of the sun, precisely blacking it out, giving us daytime where the sky turns totally dark. We'll also talk with us today with Dr. Fracknoy about the history of eclipses. It turns out that eclipses go back thousands of years into the past when ancient astronomers tried to make sense out of these celestial things happening in the night sky. What does it mean, the ancients thought, when the sun turns dark? So let's take a short commercial break, and after the break, we're going to bring on astronomer Andrew Fracknoy. Welcome back to Science Fantastic with Professor Michio Kaku. In this segment, we're going to talk about what some people call the event of the century. Don't miss it. The last time we had a total eclipse of this magnitude was 40 years ago. And if you miss it, well, you can probably wait a few more decades for the next one. So this is an event for the ages, they say, a total eclipse of the sun that'll go right across the continental United States. And with us today to talk about this event of the century is Professor Andrew Fracknoy. He's an award-winning astronomer, and he's a professor of astronomy at Foothill College in the Bay Area. And he's the author of a children's book on eclipses that we'll talk about, When the Sun Goes Dark. And also, he is part of Google and the Moores Foundation's effort to donate 2 million eclipse glasses for free at public libraries across the United States. And also, he's on the board of trustees of the SETI Institute, so we'll also say a few things about aliens from outer space as well. So, Andrew, glad you could be on Science Fantastic.
A pleasure being with you.
First question we always ask our guests is, how did you, as a youth, as a young boy, how did you first get interested in science?
Well, actually, I wasn't born in the United States, and when we came to America, I was 11 years old. And to learn English, I read lots of science fiction, comic books, and children's books, and just got fascinated by science fiction. And I remember at some point being in the library and suddenly realizing that exploring outer space wasn't just fiction. There was actually a profession where people went and did that for a living. They became astronomers. And I think from then on, I was set on my life path.
Okay. And tell us a little bit about some of the things you're doing. For example, the children's book, When the Sun Goes Dark. Tell us a little bit about that.
Well, so there is this eclipse coming up, as you mentioned, which is going to be visible not just to the people in the path of totality, but to 500 million people across North America as a partial eclipse, where the moon takes a big bite out of the sun as it covers part of it. And there's going to be lots and lots of families and kids wondering what's going on, hearing about it on the media. So my co-author, Dennis Schatz, and I wrote this book, When the Sun Goes Dark, as a way of explaining what's happening with the eclipse to kids. And part of what the story of the book does is it sets up a series of really simple at-home family activities that you can do to model an eclipse with a light bulb and a tennis ball, and to look at the way things go around the sky with hula hoops. And so we hope by reading this book either to their kids or with their kids, parents and grandparents can get the kids ready to be thinking about the wonderful science that's behind the eclipse.
Okay. Well, let's just jump right into the eclipse itself. First of all, why is this eclipse of the sun different from other ones? Because, of course, many people in the audience probably have seen partial eclipses of the sun. What's so different about this that's generating so much excitement?
Well, as you said, this is an eclipse that has the courtesy to go across the United States. We haven't had an eclipse that crossed the entire country since 1918. Being in the path of a total eclipse is very rare. We get eclipses like this regularly, but they can happen anywhere on Earth. And because 2/3 of the Earth's surface is water, often these eclipses are over some remote part of the world where only rich people can take a yacht to get there. And so here it's very nice and democratic that the eclipse is coming to the United States. Also, we think this is really the first eclipse over North America of the Internet age. And so lots more people will learn about it as they're learning through your show. And so I think there's going to be a lot more interest in the eclipse than we've ever had in an eclipse in North America.
So let's say you miss this eclipse. Let's say you're busy that day, or it's clouded over, or you simply have too many other things to do. How long do you have to wait for another eclipse like this, which is total, which crosses the continental United States?
Well, this is where we're very lucky. This is very rare, but there will be another total eclipse crossing the United States at a diagonal to this one, April 8th, 2024. So we get two of these all-American eclipses within a decade, which is really wonderful. And I'm sure the administration in Washington is going to take full credit for this once they realize it's happening.
Okay. Now, let's back up a bit. And first of all, explain to the audience, what is an eclipse? What's the difference between a lunar eclipse and a solar eclipse?
So an eclipse is when one body in the sky gets in front of another and blocks its light. In the case of a solar eclipse, we have the moon getting in front of the sun. And this, by the way, we should tell your listeners, is an amazing coincidence that as we look in the sky, the sun in the sky and the moon in the sky happen to be the same size. That's true from Earth, but not from other planets. Not from Mars, for example, they have two moons, and the two moons are not the same size as the sun, and they can't lead to a total eclipse. So we're very lucky to have this. A lunar eclipse is much more common. That's when the Earth's shadow falls on the full moon, and so it's the Earth that gets between the moon and the sun. And that can be seen by many more people, and it happens much more commonly. These solar eclipses are much more rare, and we're very lucky to have one coming to our country on a nice summer Monday in August.
Okay, then the question is, how do you go about watching the solar eclipse? I mean, Galileo, the man who took a telescope and opened up the heavens for the first time for astronomers and the average person, didn't he have some bad luck looking at an eclipse of the sun or looking at the sun and looking for sunspots?
Yes, so this is a big challenge because you know that looking at the sun is dangerous. You can really hurt your eyes by staring at the sun for any length of time. And yet here was Galileo trying to figure out how to observe the sun. And it was actually one of his graduate students, we didn't call it that in those days, but one of his helpers who came up with the idea of projecting an image of the sun through his telescope so that the concentrated light didn't fall on his eyes, but on some screen further away, and then that reflected light was much more safe to look at. And so we'll talk about how to get safe eclipse glasses for the eclipse, but in the meantime, if you don't have those, you can do the same thing Galileo did and find a way to project an image of the sun and look at that image instead of the sun itself.
Now, according to lore, Galileo actually looked at the sun with a telescope directly, without filters, without any ways of diminishing the intensity of sunlight, and apparently he scarred his retina. And according to lore, he eventually went blind in one eye. Could you elaborate on that?
Well, I'm not really privy to what happened way back then, but we do get these reports that this was the first instance where someone made the big mistake of looking through an optical instrument at the sun. And we've been working very hard in this eclipse and other eclipses to warn the public, particularly if you have binoculars, if you have telescopes, you either need to get a safe filter, which is very securely attached to your binoculars or telescopes, and the experts will have these on August 21st, or you need to project an image of the sun so you don't suffer from the problem that you just described.
Okay, now some people are talking about pinhole cameras. This is a poor man's camera where you get a sheet of paper, prick it with a pinhole, and look at the image of the sun as it shines on a second sheet of paper. Could you elaborate on some of the methods that we can use to see the sun without burning our retina?
Yes, so this is exactly right. Let me start with what I think is the most fun one, is to make sure that when you go out to look at this eclipse on August 21st, you bring a colander with you. A colander, one of those things that you use to wash vegetables or fruit, has lots and lots of pinholes in it. And if you hold the colander above your shoulder with your back to the sun, then the shadow that this colander makes on the sidewalk will show you lots and lots of these pinhole images of the eclipsed sun. And that's really fun to look at. It's a nice display, and then the colander can be a fashion accessory as well. So that's one way we're telling people. Another thing that you can do is to take a hand mirror, a compact mirror or a hand mirror, cover most of it with cardboard, leaving only a hole about a dime wide. And then use that covered mirror to get an image of the sun that you can reflect onto a wall or some other surface. And that reflected image of the sun will be bigger than a pinhole image and will be safe to look at. But as you say, having a pinhole projection, just making a pinhole in one piece of cardboard and then having a white sheet of paper some distance away also can show you a small image of the sun with a big bite taken out of it.
Okay, and what about the idea of simply getting an ordinary pair of sunglasses from a pharmacy or a neighborhood store? Do you have to be careful? Because, of course, there are different kinds of gradations of sunglasses. What about sunglasses?
Absolutely not. We can't warn our listeners enough that sunglasses are not enough, polarized glasses are not enough. If in the old days when we still had film photography, people talked about having dark negatives and using them to shade your eyes. None of those are safe to look at. Please don't use them. There are Eclipse glasses made of special mylar material, which cuts out a lot of the sun, and we'll talk later about how you can get one of those glasses. But just using sunglasses is really not enough. So especially if you have kids or you have a family, make sure you warn them about not relying on regular sunglasses.
Now, I would assume that the average person, not knowing this, will get, for example, an exposed photographic film or a piece of glass that's tinted and try to look at the sun through that, right? I mean, you're telling me that that's not the way to go, right?
That's right, and I think that's part of what we're doing. I'm on a national task force for the American Astronomical Society, and we've been trying to get the word out to the media. We have resolutions from various medical societies, and so I think there'll be a lot of warnings on the days and weeks before the eclipse for people not to do that. The only thing that does work in this way is welder's glass. If you know a welder or if you do welding for a hobby, a welder's glass or welder's glasses number 14 or higher are safe. But anything below number 14 is not okay. But again, the best thing is for you to try to get one of these inexpensive paper-framed mylar glasses called Eclipse viewing glasses. Those are the safest and I think the most fun to use on August 21st.
Okay, and you mentioned it before, but you're working with Google and the Moore Foundation to get them to donate 2 million Eclipse glasses for free at public libraries. So tell us a little bit about this effort that you're spearheading to donate 2 million glasses for free, and how can the average person listening to the show get one of these glasses?
Well, this has been very gratifying. We worried for a long time about how we were going to get these glasses distributed. They're not that expensive. It's just that we were going to have hundreds of millions of people who probably would like to have one. So we thought maybe a big company like Starbucks or Target would distribute them, but that didn't quite work out. And then we hit on this idea that there is already in each community across the United States an institution in the business of information distribution, and that's the local public library. So as you mentioned, we were very lucky to get the Gordon and Betty Moore Foundation and Google to donate 2 million Eclipse glasses. Now, by the way, we've just learned NASA's throwing in another 100,000 glasses for libraries. And these have been sent now to about 5,000
Okay, Andrew, unfortunately, we have to cut you off. We're going to take a short commercial break, and after the break, we're going to continue a discussion of the eclipse of the century. Plus, we'll say a few things about the history. Eclipses have a long, colorful history. We'll talk about that as well. And you are listening to Science Fantastic with Professor Michio Kaku, and we're talking about astronomy, the heavens, and what's going to happen on August 21st. People call it the eclipse of the century. If you miss it, sorry about that.
This is Science Fantastic.
Science Fantastic with Professor Michio Kaku. With us today is astronomer Professor Andrew Fracknoy, and we're talking about what some people call the eclipse of the century. For the first time in 40 years, the people of the United States can witness a spectacular total eclipse of the sun. And we think that hundreds of millions of people will be flocking to that band across the United States where you can see a total eclipse of the sun. With us today is Professor Andrew Fracknoy, Professor of Astronomy at Foothill College in the Bay Area, south of San Francisco. He's the author of a children's book, When the Sun Goes Dark, and also he's spearheading this program to get 2 million eclipse glasses donated for free via public libraries. So let's say it one more time. What is the wrong way to see the solar eclipse of August 21st, and what is the correct way, and how do you get one of these eclipse glasses for free from a public library?
So let's be very clear. If you're lucky enough to be in the 60-mile wide zone, which stretches from Oregon to South Carolina, where you can see the completely total eclipse during the 2 minutes when the sun is completely covered by the moon, you don't need any kind of protection. Then it's perfectly safe to look at, and it's one of the most awe-inspiring and beautiful sights. But any time that even a little piece of the sun is showing, if the sun is only partly eclipsed, which is what most of us will see throughout the United States and Canada and Mexico, then you need some kind of protection for your eyes. And sunglasses won't do it, darkened glass won't do it, Polaroid glasses won't do it. You need much better protection than that from the intense light of the sun. And as you said, one of the best things are these paper eclipse glasses with a special mylar plastic which cuts out most of the light of the sun. And we were very lucky, we were just talking about in the last segment, that we were able to get more than 2 million glasses donated. Ultimately, we think to 6,000 public libraries. We're getting another 1,000 or so involved in the next few weeks. And so most public libraries that are participating in this already have their glasses. So your first thought should be to ask your public library, are you part of this program to distribute eclipse glasses, and may I have a pair of glasses? Now, if it turns out that they've run out or that your library is not participating, there are 2 companies in the United States that make these glasses. One is called American Paper Optics. The other one is called Rainbow Symphony. And you can Google them and find out more about how you can get your own glasses. Also, many places will be selling them. I think Walmart is going to sell them. We know that most science museums in your community will sell them, and many colleges will have in the bookstore these special glasses available. So if you call around your community, you might find a number of sources where you can get them. Probably best to get them early, because as more and more people wake up to the eclipse, there will be a great demand for these eclipse glasses.
Okay. And by the way, is there a website that people can dial into to find out more about your work and more about the solar eclipse and how to watch it safely?
Well, yes. So we're working with the nonprofit National Science Teachers Association. They published that children's book that you were nice enough to mention, When the Sun Goes Dark. And they've put online for free an 8-page booklet all about the eclipse, where it's going to be visible, in what way, what it's like in different cities, and various methods of watching eclipses safely. And that free booklet is available at the website NSTA.org. NSTA is National Science Teachers Association. So NSTA.org/solar science.
Tell us a little bit about the mythology of eclipses, starting with Mark Twain.
I will, but if I may, I just want to make sure that we give the correct web address, because NSTA.org by itself is not enough. It's got to be NSTA.org/solar science. The word solar science, all one word. That'll get you to the page where you can get that free 8-page booklet. But let me answer your question. Absolutely, the eclipses have been known. They were observed for a long, long time, going back into prehistory. And for most of history, they were very scary, because it looked like, to the ancients, some monster was coming and eating the sun, making it go dark in the middle of the day. And so people developed all kinds of legends about this, and they also developed a very clever solution. They said, if a monster is eating the sun, what we need to do is frighten that monster away. So in many countries, there was this long tradition that when you see an eclipse, you bring out pots and pans, and you bang them together really loud, making a huge noise in your village, and that will frighten the monster and will leave the sun alone. And you know what? It always worked. The sun eventually came back. And as you say, eclipses have inspired literature and music. Mark Twain, in the story The Connecticut Yankee in King Arthur's Court, had the modern protagonist know something about eclipses and therefore seem very powerful by predicting an eclipse that we already knew had happened back in time, but the people at the time were amazed that he could predict. And lots of things about eclipses. There are pieces of music. Carly Simon's song, You're So Vain, makes a reference to flying up to Nova Scotia in a private jet to view one of these eclipses. And that's really, I think, what's exciting about this eclipse is that unlike many eclipses where only rich people get to see it in some remote part of the world, here we're going to get everybody in the United States to see at least a partial eclipse of the sun.
Now, isn't it also true that because we know the precise date of these ancient eclipses, we can use that to date historical events and historical manuscripts? So if we have an ancient manuscript that refers to an eclipse, we can pretty much narrow it down, plus or minus one or two eclipses of when it happened, right? So can't we also use the eclipse as a way to date things?
Absolutely. So this has been, I think, one of the most remarkable successes of astronomy is that by understanding the motion of the solar system, the ballet which the planets dance in the sky, and the moon and the sun, as they move from Earth, appear to dance in the sky. By understanding this very precisely, we can not only predict when eclipses are going to happen in the future down to the minute, and you can find, by the way, tables of future eclipses and where they are on the web if you Google this. Not only can we predict them in the future, but we can go back in time, as you suggested, and find when all the eclipses of the past happened. And since eclipses were a big deal in history, we often find references to them in manuscripts, on tablets, and historical records. And so we can then use our understanding of when the eclipses happened to date events.
Okay. Andrew, we have to take another short commercial break, but after the break, we're going to talk about, intelligent life in outer space, because you're on the board of trustees of the SETI Institute.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. We're talking about, what some people call the eclipse of the century. Well, once again, with us today is Professor Andrew Fracknoy, and he's also on the Board of Trustees of the SETI Institute. And a few weeks ago, we had Dr. Seth Shostak talk to us about aliens from outer space. So, first of all, do you believe that there are, in fact, alien civilizations out there that one day perhaps we can make contact with?
Well, of course, as you know, in science, belief is not the important thing. It's what the evidence is. But yes, based on the evidence, particularly the exciting news that I'm sure you've talked about on your show, that we are finding thousands of planets orbiting other stars now, that in the last 25 years this has changed dramatically in science, and we now know not only that there are families of planets around many stars, but even that there are Earth-like planets out there. This has made us, I think, a lot more optimistic that life on Earth isn't some unique thing, but that conditions elsewhere may be the same or similar enough so that life, and perhaps even intelligent life, could exist on many of these worlds.
And here's the killer question. Where are they? I mean, after all, they don't land on the White House lawn announcing their existence. Here we are, folks. They don't promise us advanced technology, blah, blah, blah. Hollywood, of course, has an whole industry around this. So the question is, if they're out there, then how come they don't land on the White House lawn?
Well, as you say, there is a whole industry. This is sometimes called Fermi's paradox or Fermi's question. And there are lots and lots of answers to this. But let me just tell you some of my thoughts about this. First of all, the stars are really far away, and it takes a long time to get there. So, for example, the fastest spaceship that the human species now has would take almost 70,000 years to get just to the nearest star. It's hard to find graduate students to volunteer for a trip like that, by the way. But in any case, this is something which probably makes travel either very slow or, if we want to go much faster, very, very expensive. And that's what makes us think that probably we're not going to make contact with aliens by traveling as much as by sending messages, just like we're communicating with the show's listeners at the speed of light using radio waves. And the information you get from the radio station that you're listening to your house or to your car almost instantly at that speed. In the same way, we think that species might communicate using waves that travel at the speed of light. And part of what we do at the SETI Institute is to search the sky for indications that some sort of intelligent signal might be coming from the stars.
Now, Dr. Sostak on the radio said something which kind of surprised me, but actually makes a lot of sense, something that I've thought about, and that is if they really are out there, alien civilizations, they could be thousands, millions of years ahead of us, in which case they may be partly robotic or cybernetic, in which case maybe they don't use radio at all. Maybe they have completely different criteria for life, because with a robotic body, you don't have to be on an Earth-like planet at all. You can be pretty much anywhere you want to be if you are a Superman and have an invulnerable robotic body. So what are your thoughts about the fact that maybe we've been barking up the wrong tree, thinking that they're just like us, when they could be very much different from us? What are your thoughts?
Absolutely, and it's very difficult to predict life as we don't know it, which is why we scientists tend to stick to life as we know it. But absolutely, that's correct. There may be civilizations so far in advance of us that they're really way beyond what kind of technology we're just starting to develop. On the other hand, there may be civilizations that are still not exactly at our level, but not that far advanced. Or there may be, my favorite scenarios, that there may be civilizations where their equivalent of seventh graders still do science fair projects. And you know how in a science fair project you often duplicate a science experiment from long ago. That's a big deal to you, but not to scientists. So my favorite scenario is that there's a seventh grader out there in some advanced civilization that is doing a project that is way better than anything we can do now. But because he's doing an old project, he's sending the kind of waves that we can still pick up. And it's one of these seventh grade science projects that the SETI Institute will find when it's searching either for radio waves or for laser signals from the stars.
Okay, also, it's the anniversary, 70th anniversary of the Roswell incident of 1947. Some people swear by the fact that the United States government recovered dead bodies of aliens from a crashed flying saucer. So I'm sure that you probably get lots and lots of photographs and testimonials claiming that they've been abducted by flying saucer people. What are your thoughts?
Well, so we now know exactly what happened in Roswell. There was a weather balloon that was part of a top-secret project to send balloons up to get the pressure waves of Russian nuclear tests. And one of those top-secret balloons crashed at Roswell and then was whisked out of sight. The name of the project was Project Mogul. You can Google it. And so we now know exactly what that crash was about. But you're right. Lots of people see lights in the sky, and they mistake them for aliens and alien spaceships. So far, we haven't had any spaceships come to Earth which have left behind a little picnic garbage or a piece of the ship that fell off that we can test in a laboratory and see that it's not made of earthly materials. So we're waiting for that. Nobody would be happier than astronomers if the aliens were coming here and ready to talk or to tell us more about the universe. But so far, we're waiting for the evidence.
Well, I'm afraid that's it for Science Fantastic for this segment. Our special guest today has been Professor Andrew Fracknoy of Foothill College in the Bay Area, south of San Francisco. His book for children is When the Sun Goes Dark. And once again, if you want to find out more about his work, go to nsta.org/solar science, and perhaps you can be one of the people with a special eclipse class to witness the event of the century.
This is Science Fantastic. Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because this hour is your hour. Okay, let's move right along to the first listener phone call.
Yeah, my name is John, calling from northeastern Tucson, Arizona. My question is in regards to magnetic propulsion systems, so to speak. Using magnetic propulsion system as a launch platform and why we haven't done that for orbital spacecraft, why we haven't done more on that side of things.
Okay, well, you're absolutely right. Some people have proposed what is called the electromagnetic railgun. So far, we use chemical explosions in the form of gunpowder in order to shoot projectiles to the moon and projectiles outside of guns. However, other people have proposed using railguns, which is almost like something from Buck Rogers. A railgun consists of two long metallic rails. On the rail, you put a projectile that straddles the two rails. You send a current surging through these two rails, and by Faraday's law and whatever, the object that you put on the rails straddling the two rails is accelerated as the charge moves along the rail. Now, these rail guns are so incredible that the air friction that the object encounters when it hits the air is enough to flatten it. When was the last time you saw air flatten metal? That's what happens because these rail guns move so fast. In fact, it's projected that the military will one day be able to launch satellites using rail guns from the planet Earth. I mean, this is wild. Think about this. Having a gun that can launch a satellite. No need for booster rockets, first stage, second stage booster rockets. No, a gun that can launch a projectile into outer space. Now, what's the catch? Well, there's always a catch someplace. First of all, the railgun accelerates an object almost instantaneously. Therefore, the G-forces are incredible. The G-forces are so great that it would flatten steel. So if you have an astronaut that's going to be blasted into outer space with a railgun, he will be flattened like a pancake because of the sudden surge of acceleration that takes place in a railgun. So in an ordinary rocket, the rocket accelerates rapidly, but it doesn't crush the astronauts. The astronauts only feel maybe 2 or 3 times the force of gravity. However, with a railgun, it's sufficient to flatten steel, let alone bone and human flesh. So who's interested in railguns? Well, obviously the military. The military has experimented with railguns. In fact, you can even build a railgun inside your own garage. I've seen high school students that have actually created railguns inside their garage. Now, of course, these railguns do not attain 18,000 miles per hour, which is the orbiting velocity of an object necessary to go into orbit. However, yes, even high school kids for a science fair project can build a railgun, which of course can accelerate pellets of steel at enormous velocities. So the military, of course, wants to have industrial quantities of electromagnetic pulses. And for them, yeah, what they want to do is to create a weapon that can be used. And again, the problem with railguns is that in some sense they are victims of their own success. They are so successful, they will flatten steel, making most projectiles impractical on a railgun. But again, that doesn't prevent the military from dreaming about the day when they may have Buck Rogers weapons. Now, obviously, if air pressure and friction is a problem with railguns, why not put them into outer space? In outer space, there is no air. There is no air friction that slows down or flattens steel. And then, of course, it would be quite possible to shoot objects almost instantly outside of a railgun to use as a weapon. So yes, the military has in fact looked at that possibility as well. Okay, let's move right along now to the next listener phone call.
My name is Norman. I'm calling from Anderson, Texas, and the radio station is WTAW. And my question is that if there is a consensus of scientists that agree on a certain scientific principle or theory, does that make it fact? Thank you.
Well, you ask a very interesting question that goes to the heart of science, and that is science done by a vote? Do scientists simply vote on something and they deem it to be correct? And the answer is no. Science is based on three things. It has to be testable, it has to be reproducible, and it has to be falsifiable. That's a criterion for science. And if somebody comes along, the next Einstein, and shows that the previous set of theories are wrong, then we have no choice but to adopt the new theory. That's why many people call scientists revolutionary conservatives. That for the most part, scientists are very conservative. They don't go by majority rule. They simply go by what is experimentally verified. However, if one experiment doesn't fit the data, if one experiment shows that the previous theory is wrong, then scientists become revolutionary, because you cannot argue with data, especially data that is reproducible, falsifiable, and testable. Now, let me give you an example. Just before the outbreak of World War II, Albert Einstein was famous even at that point, but the Nazis didn't like that. The Nazis called relativity Jewish physics. And so the Nazis assembled a book. It's a very famous book. The title, in German, read 100 Authorities Denounce Albert Einstein. In other words, they interviewed and took statements from 100 of German scientists, the cream of German scientists, to be put in a book denouncing the work of Albert Einstein. Well, the media went to Einstein himself, and they asked him, what do you think about the fact that 100 of your peers, 100 of the finest scientists that Germany can produce, have written a book denouncing your theory? And Einstein replied, you don't need 100 authorities. You need one fact. One simple fact would violate all the theory of relativity. But of course, nobody could create even one simple fact. Okay, well, let's move right along now to the next listener phone call.
Yes, hi, Professor Kaku. My name is Brian. How far out do you think we are until we will be able to have the technology to capture and record thoughts and dreams, both visually and audibly, and be able to play them back as you would any film or video or even something you see on YouTube?
Well, 5 years ago, if you were to ask that question on Science Fantastic, the response would have been, ha, humbug, come on, give me a break. No way. Well, times have changed. In fact, in my latest book, The Future of the Mind, I actually go through documentation by which one day we may be able to do exactly that. That is a Technicolor with sound videotape of the dream that you had the previous night. What I did was I went to Berkeley, where I got my PhD so many years ago. I visited the neurology laboratory there, and yes, they do it. They can actually begin to photograph thoughts. Here's how you do it. You put a subject in an MRI machine which can calculate blood flow in 30,000 places in the human brain. That's how accurate MRI scans are today. They can actually calculate blood flow in 30,000 locations in the living brain. Now, where there's blood flow, there's electrical activity, because that means you're thinking. Therefore, second by second, you can actually see thoughts. Thoughts go ricocheting from one part of the brain to another part of the brain to another part of the brain. Then what they do is, when you're looking at a picture, the MRI scan of your brain is fed to a computer. The computer then analyzes blood flow in 30,000 dots and then, ta-da, prints out a picture of what you are thinking about. This is amazing. And if you fall asleep, the machine keeps on going and prints out a picture of what you are dreaming about. So I had a demonstration of this when I visited the laboratory myself. And I saw these pictures. First of all, I saw pictures of what you are looking at. If you're looking at an elephant, for example, by golly, the computer assembles a picture that roughly looks like an elephant. If you look at a human, yes, the computer will print out a picture that really does look like a person with head, eyes, nose. Now, when you go to sleep, it's much fuzzier, of course. However, it still prints out a picture. The pictures are not so spectacular, very, very fuzzy. But the very fact that I can even talk about this is amazing. Once considered preposterous, and now we do it in the laboratory at the University of California at Berkeley. Now, you mentioned sound. Sound would be a little bit more difficult because sounds are generated through the left part of your brain. The left brain generates sound. The back of the brain assembles visual images. However, we're going to get to the point where we can even begin to digest sound as well. We're not at that point yet, but as I said, we are at the point where even if you are dreaming, we're able to photograph the image of your dreams using computers. Now, this is a very fast-paced field, of course, as we begin to have what is called brain-computer interface. Telepathy is already possible by thinking certain thoughts. In the future, you'll be able to type. Think about that. Typing a document simply by thinking about it. This is almost within the realm of possibility today. And my colleague, Stephen Hawking, who is paralyzed, of course, the next time you see him on TV, look at his right glass. In his right glass, there's a chip. That chip picks up radio signals from his brain and then processes it and types messages. And so that's how Stephen Hawking communicates with the world today, by thinking and communicating through a computer. So in other words, in the future, we'll have BrainNet. We'll have images. We'll have sound, feelings, emotions, memories sent on the Internet. Okay, let's move right on to the next listener phone call.
This is Eric. I'm calling from Texas. Have scientists developed a strategy as to when the day comes we contact intelligent life, how we will do it? I mean, will it be verbal, written, or will it be through hieroglyphics or sign language? Thank you very much.
Well, you ask an interesting question, and the answer to the question is no, we scientists have still yet to come up with a uniform protocol and a uniform method by which to decode signals from outer space. But if you saw the movie Arrival, then you realize how difficult it is to do that. In the movie Arrival, the aliens land from outer space. They hover over our cities, and we're able to get into their spaceships where we meet them. They look like giant squids, in fact. And they give us sign language that looks like spherical blobs of ink, like a Rorschach chart. And linguists have to decipher these messages. Now, of course, this is a very clumsy way to do it. I would think that aliens from outer space are so advanced that they have already deciphered our language, and we don't have to use clumsy sign language, for God's sake, to communicate with them. They'll speak perfect Hollywood English, because they've been monitoring us. If they're that advanced, they've already deciphered our languages and can speak to us in any language they want. But you ask a different question. Is there unanimity with regards to the protocols, with regards to the way in which we decipher messages from outer space? And the answer is no. no protocols, no uniform way of deciphering messages. Now, to be fair, it's very difficult to decipher a message because these aliens may not look like us or even think like us. For example, think of a dog. Maybe these aliens are descended from intelligent dogs, in which case their mind is full of smells. If you were to brain scan a dog, you'd realize that dogs don't necessarily communicate with verbal signals. They communicate through smells, thousands of different smells swirling around their brain. Or think about it. If they're descended from intelligent bats or intelligent dolphins, they'll use sonar. They won't use sound at all. And bats, many of them are blind or have very poor eyesight. They won't even use visual signals. They'll use sonar in order to communicate, in order to convey messages. Or take a look at bees. Bees don't even use visible light. They use ultraviolet light in order to navigate, and they dance. The way they communicate is by dancing to locate, for example, a flower bed. So aliens from outer space may be much different than bats, dolphins, bees, much more different than dogs or cats, and therefore who knows how they will communicate with us. However, I personally believe that one day if we make contact with them, they'll be so advanced that they will have already mastered American English. Well, let's move right on to the next listener phone call.
My name is Frank. I live in Pennsylvania. My question is, the building blocks of the universe, the scientists always talk about them, but I'm wondering, did it take an intelligent creator to create the building blocks to build the universe? And if so, how could the creator create itself if there is nothing out there in the universe? Thank you.
Well, you are asking the $64,000 question for which there's no unanimity of response. However, let me try to break down your comments piece by piece. First of all, we do have the atomic theory. And the atomic theory allows us to create transistor radios and lasers and rocket ships and all sorts of wondrous chemical and physical devices that you see in your living room. Science without the atomic theory would be like going back to the Middle Ages when we had witchcraft and hocus pocus, right? However, then the question is, well, where did these atoms come from? Well, now we think that atoms are made out of something called quarks that make up the proton. 3 quarks make up a proton. Then the question is, well, where do the quarks come from? Well, we think they come from strings, tiny little vibrating strings. Each note on a vibrating string corresponds to a subatomic particle, and that's why we have so many subatomic particles. They're nothing but musical notes. So if string theory is correct, and it has not yet been verified experimentally, it means that physics is nothing but the harmonies of vibrating string. Chemistry is nothing but the melodies you can play on strings. The universe is an orchestra of strings. And the mind of God that Albert Einstein wrote about for the last 30 years of his life, would be cosmic music. Cosmic music resonating through 11-dimensional hyperspace. That would be the mind of God. But then the question is, as you ask, well, then where did God come from? And it goes on and on and on. Where did that come from? Where did that come from? Well, ultimately, we want to find what is called the God equation. That is an equation, when it's long, that, according to Einstein, would give us all known physical law. That's the theory of everything. The closest thing we have that today is string theory, but then some people ask the question, well, where did string theory come from? Did it come from intelligent design? Well, the short answer is we don't know, but let me tell you what Einstein thought about this. Einstein was asked the question, is there a God that gives us relativity and the quantum theory? And Einstein said, well, you got to be careful. There really are 2 kinds of God. First is the personal God, the God that smites the Philistines, the God that wipes out your enemies, the God that gives you that bicycle that you've always wanted for Christmas. Einstein did not believe in that God. He didn't believe that God that created the universe existed just so that we can smite our enemies and get bicycles for Christmas. No. He believed in the God of Spinoza, the God of Leibniz. That is the God of harmony, the God of beauty, simplicity, elegance. He believed that the universe was so beautiful that it could not have been an accident. It could not have been a byproduct of random events. The universe is not chaotic. The universe is not random. The universe is not messy. It's quite ordered. And so that's why Einstein thought there was a God. Not a personal God, but the God that gave us the original one-inch equation, the God equation, that allowed us to give us the universe. So where did that equation come from? Well, it came from the God of Einstein. Okay, let's move right along now to the next listener phone call.
Hi, this is Jared calling from Florida. I was wondering if you had any thoughts on I believe it's called the infinitesimal possibility. I might have that wrong, but it's the theory that if the Big Bang had happened at a fraction of 0.0000 going on for infinity with a 1 at the end, greater or smaller, that the Earth would not have happened. That the Big Bang was just so perfect we would not have existed had it been slightly different in any instance. And if that's the case, how could there possibly be life on another planet or anywhere else in the universe? Thanks for your thought.
Yes, you're asking what is called the anthropic problem, and that is the universe seems to be designed. That is, it seems as if it could not have been a pure accident. For example, the nuclear force, the gravitational force, they are just right to make possible life as we know it. For example, if the nuclear force were a little bit stronger, it would mean the sun would have burnt out billions of years ago, and the Earth wouldn't be here because the sun would have become a cinder. If the nuclear force were weaker, a little bit weaker, then the sun would never have ignited to begin with, and it would be all dark, and we wouldn't be here. And so the nuclear force is just right to make possible intelligent life. Also, take a look at gravity. If gravity were stronger, then we wouldn't have necessarily the Big Bang, but a big crunch. All the stars in the galaxies would have been crunched together if gravity were stronger. If gravity were weaker, the universe would have blown apart billions of years ago, and things would be cold, and the solar system wouldn't exist. So if gravity were weaker, the stars, the galaxies, would have flown apart billions of years ago. So gravity is just right to make possible life. Well, it goes on and on and on. How many Goldilocks zones are there that has to be just right to create life? It turns out there are many Goldilocks zones. So many, in fact, that some people have claimed, therefore God exists. God chose the universe to be just right from the sun, just right so that we have stars and galaxies. Otherwise, we wouldn't be here to talk about the problem. Now, what are the pros and cons about the anthropic principle? I was first introduced to this by my second grade teacher. I'll never forget, my second grade teacher came in one day and said that God so loved the earth that he put the earth just right from the sun, not too close when the oceans would boil, not too far when the oceans would freeze, but just right to have life. That's how much God loved the earth. Well, today we have discovered 4,000 planets where the planets are too close. They are too far from the mother sun. Very few of them are just right from the sun to have liquid oceans. In other words, the solution to that problem is, well, two solutions. One, maybe there is a God. Two, maybe there are lots of dead Earths out there. So the answer to your question is, there are two possible solutions to the anthropic problem. A, maybe there is a God. Maybe there is a designer that designed the nuclear force, designed gravity to be just right so we have stars, we have galaxies, and we have Earths. Or there are dead universes out there. Universes where the nuclear force never ignited the stars, where there are no stars. Or universes where there's a big crunch, where all the matter squeezes together and simply goes out of existence. Which is correct? Well, the first theory, as I said, is called the anthropic problem. The second theory is called the Copernican principle. The Copernican principle is the opposite of the anthropic principle. It simply says the universe is not special. The Earth is not special, said Copernicus, and the universe is not special at all. In other words, there are dead universes out there where the universe does not tolerate life as we know it. Now, which is correct? Well, these are two philosophies. They're not testable because to test it, we would have to create alternate universes. But there are two philosophies, both of which are compatible with every single data point, every single experiment ever done in the history of astronomy. The anthropic principle, which says the universe is so special, maybe it was designed along now to the next listener phone call.
Hi, this is Jeff. I'm in Fairbanks, Alaska. I had a question about light. I've observed two intersecting shadows, and where they intersect, it's actually darker. How does that happen? I was wondering if you could expound on that. Thanks.
Yes, well, if you look at a shadow very carefully, you'll see that the shadow is not just pure black or pure white. The center of a shadow is darker than the outside. And why is that? Because of scattered light. Light, of course, moves in a straight line, but it ricochets, it bounces off things. And as a consequence, the rim or the outer layer or the outer part of a shadow is dimmer than the center, which tends to be blacker. Therefore, if I put two shadows together, the intersection of two shadows is even darker than each shadow individually because of scattered light. Now, the question of shadows, as you mentioned, was also interesting because there's a conspiracy theory that says that we never went to the moon, that the moon program was faked by Hollywood, and to prove that, they say that our flag did not flutter like the movies show because there's no air on the moon. And second of all, the shadows, not one set of shadows, but two sets of shadows. Obviously, shadows created by the lights of a Hollywood studio. So how do we scientists answer those two questions? Well, first of all, yes, the flag that flutters on the moon flutters as if there was air on the moon because there's tinfoil. The flags are made basically out of a tinfoil-like material, and that's why the flag seems to flutter even if there's no air on the moon. That's how we explain that. Second of all, what about the double shadows? Well, you have to realize that Earthshine is something that we're not accustomed to seeing. On the Earth, we have moonshine. At night, moonshine casts shadows. However, on outer space, in the moon, we have Earthshine. And so we have more than just one shadow on the moon. We have the shadow created by the sun and the shadow created by the Earth because there is Earthshine on the moon. Also, take a look at the fact that even North Korea, a country that's starving on the verge of collapse, can actually send satellites into orbit. So in other words, it's not such a big deal to go to the moon. So some people say it's impossible that we could go to the moon because it's so advanced. However, even North Korea can send an object in orbit around the Earth. So why did it take America to go to the moon? The problem is not going to the moon. The problem is coming back from the moon. That took the United States of America. Very few countries can get astronauts back from the moon safely. We did it. Now, to go to the moon is not so difficult. Quite a few nations have actually sent probes to the moon. In fact, the Chinese have sent probes to the moon, and in 2025, they want to have their astronauts put a flag on the moon, a Chinese flag on the moon by 2025. So going to the moon is not such a big problem. It's coming back. That's what America can do that very few other nations can accomplish. Okay, let's move right along now to the next listener phone call.
My name is Jim from Texas, and I'm wondering, when do we know too much?
Well, some people would say that maybe we already know too much. Well, as Einstein once said, our technology far exceeds our humanity. In other words, we have the technology. We know so much about the atom that we can split the atom and thereby destroy all life on the planet Earth. So that's our technology. Our humanity, however, has not liberated us. We still live with wars and famine and all sorts of disruptions of our environment. So here's an instance where our knowledge exceeds our humanity. So in some sense, we already know too much. Now look at it this way. our personality hasn't changed much in 200,000 years since modern humans first emerged from Africa. You could take one of these cavemen from 200,000 years ago, give them a shave, put on some aftershave lotion, get them in a three-piece suit, and put them on Wall Street. And they'll look like all the other barbarians on Wall Street. We haven't changed that much in 200,000 years. But today, we have the internet. Today, we have nuclear weapons. Today, we have designer germs. Today, we have the capabilities of wiping out life on the planet Earth. But our personality hasn't changed much. For example, if there's a nuclear war and all central governments fall apart and we have food riots, humanity would degenerate into a bunch of barbarian tribes. Yes, strong men commandeering food and weapons would take us back a few thousand years into the past. So we humans like to think that we're so advanced, but in some sense we know so much without the humanity necessary to bind us together that one mistake and we could be sent back thousands of years into the past, back to the age of feudalism and warlords. Okay, well, let's take the next listener phone call.
Hi, this is John from Tampa. Dr. Kaku was talking about black holes, that instead of, I guess, the singularity forming into a dot, it turns into a ring. That it's possible that that could be a gateway, maybe from one universe to the next. And I guess my question is, okay, it's a gateway. Let's say a person falls into that ring. What happens to the matter of which he's made of? Is he going to be ripped apart and all that? Assuming he does, that is, the ring is a gateway. How is he spit out? Is he going to be the person, let's say, or is a rocket that's sent through there or a probe going to be the probe, or is it just going to be a bunch of mush?
Well, it turns out that as you approach a very large black hole, gravitational radiation and forces are not so great. The bigger the black hole, the weaker the gravity is as you enter the black hole, and therefore you will not be torn apart. In fact, it was mathematician Roy Curry in 1963 who proved that mathematically, that if you have a spinning ring, you are not necessarily ripped apart, that you may actually go through the ring into a parallel universe without being ripped apart if the black hole is large enough. Okay, well, unfortunately, we have run out of time. Once again, you've been listening to Science Fantastic with Professor Michio Kaku.
Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries that are revolutionizing our world and touching our lives. And once again, in this hour is your hour. This is the time when you can get to the phones. Okay, let's move right on to the listener phone call.
Hello, Dr. Kaku. I listen to you on KNSI Radio, 1450 AM in St. Cloud, Minnesota. On July 4th of 1947, supposedly a spaceship landed in Roswell, New Mexico. And being that it's the 70th anniversary coming up, I was just curious your thoughts. Did that really happen? I enjoy your show. Thank you very much.
Well, a complete answer to the question of the Roswell incident would take up the entire hour. But let me just summarize, because on radio I've actually interviewed the leading skeptic and one of the leading promoters of the Roswell controversy. So let me try to summarize briefly their particular points of view. First of all, I had an official from the Air Force who came on radio. And he said that no, it wasn't aliens from outer space. First of all, it was basically a weather balloon. It was something called Project Mogul, and the weather balloon crashed. And some people thought that the debris left over from the crash was evidence of aliens from outer space. And therefore, there's nothing to worry about. There are no dead bodies of aliens, and we did not reverse engineer these things, the Air Force official said. But then we had the skeptic come on and say, wait a minute. If the Air Force is so confident that it was a weather balloon, then how come they tried to hide it? How come they tried to disguise it? How come they've been giving so many false press releases and false leads? how can we believe anything that the Air Force says, given the fact that they've been changing their story all these years? Well, the Air Force person came back and said, okay, he'll admit that, yes, the Air Force has been changing its position, but there's a reason for that. And the reason is the Air Force actually allowed a lot of the Roswell stuff to get out of control because they were testing advanced weaponry. For example, the stealth bomber, also the flying wing. Different experimental aircraft were being experimented with. And of course, you can't experiment with these aircraft over civilian cities. You want to do it over a desolate area, and that's where Roswell came in. So the Air Force person said, yes, the Air Force has been sending out fake press releases. The Air Force has been trying to cover up the fact that it was, in fact, secret missions like the stealth bomber, the flying wing, and other experimental designs that they were playing with. So, therefore, he said, it's still not a flying saucer. Well, then the promoter of the Roswell incident comes back and says, well, we now know that the United States Air Force and military were actually dumping radiation into people's backyards. How can we believe the government if the government has been secretly releasing radioactive materials, radioactive uranium, into people's backyards without their permission? This was revealed by several newspapers in Albuquerque about 10, 15 years ago, made big national news. The fact that one of the reasons why there was this incident at Roswell is because the Air Force was secretly, the United States military was secretly releasing radioactive materials to test how far they would disperse into the environment. Well, this, of course, was very embarrassing to the Air Force and the military, but they still claim it was, in fact, not a flying saucer. Well, then the Roswell person came back and said, well, they're eyewitness accounts. Eyewitness account, there's one nurse who claims to have actually seen the alien with big eyes on a stretcher, and therefore an eyewitness account indicates that there was an alien that was seen there. Well, the Air Force person came back and says, come on, what really happened was the United States Air Force was testing what happens if you jump out of an airplane miles above the surface of the Earth in order to test what would happen to astronauts. And so in one test, there was a test pilot who survived this very long jump, but he did sustain damage. Basically, when you're exposed to very low pressures, the blood inside your body begins to expand, and it caused him to have a very swollen face. And the Air Force even released a picture of this poor test pilot, showing that he looked very much like an alien. His face was totally swollen. His eyes were bulging out because of the fact. And so, in other words, the famous picture of the aliens that you see on every cereal box and every notice about the Roswell incident is really based on an actual photograph of a test pilot as he was jumping out of an airplane miles above the surface of the Earth in an experiment. Well, as you can tell, the debate went back and forth for a full hour. Tit for tat. This exposure, this fraud, this statement, back and forth, back and forth. Now, the average listener listening to this might be a little bit dazzled by the incredible flood of information, but let me try to summarize. First of all, the Air Force has now come out with a book that goes through the Roswell incident, the book that then debunks point by point, all the different so-called eyewitness accounts of seeing aliens from outer space and so on and so forth, saying that it was basically Project Mogul. It was basically a weather balloon that crashed. Okay, that's the Air Force position. Then the position of the true believers is, well, why should we believe anything? The Air Force admits, the government admits that it's been lying all these years about Area 51, about Roswell. The Air Force and the military now admit that, yes, they did plant false stories. They admit this now to cover up the fact that they were doing unauthorized experiments on radiation that was basically dumped into the air over people's backyard to test what would happen in an actual nuclear war. So after everything was said and done, well, I think it was a draw. That is, tit for tat, you could make an argument that the Air Force position is credible. They were able to rebut every single statement made by the true believers. However, the true believers don't believe any of it because the Air Force and the military has been lying to us all these years. Now, however, if you have been abducted by a flying saucer from outer space, I advise you one piece of advice. Steal something. I don't care what it is, a paperclip, a chip, steal something. So afterwards you have something tangible to say to the press. So often we get emails from people saying that, yes, they've been abducted by aliens from outer space. Hideous experiments were performed on them, and they want to tell the world. But you see, there's no evidence one way or the other. We could settle the whole thing right now. If you have alien DNA, if you have an alien chip, an alien paperclip, I don't care what it is, alien technology with alien metals, that would end the thing right there. Otherwise, we're left with hearsay. Okay, let's move right on to the next listener phone call.
My name is Bob. I'm calling from Minnesota, and I was just wondering, how would you break down a neuron, and what is an atom? And I think your show is great. You guys have a wonderful day.
Okay, great. Well, the word atom is Greek for cannot be cut. A means cannot or no, like atheist means you do not believe in God, for example. A means you cannot, and tum means cut. So atom means you cannot cut it. In other words, it's the smallest unit of matter, said the Greeks. Now, how do they argue that? They argue that by looking at a gold ring. If you look at a gold ring over the years, over the decades, it begins to wear down. It gets smaller the older it is. But on any given day, you cannot see any of the gold being released by the ring. Therefore, said Democritus, there are invisible things called atoms beyond which we cannot cut that make up everything. That's the atomic theory. And the atomic theory is great because it explains the laws of gases. It explains the properties of liquids. It explains pretty much what we see with ordinary matter, the shape of crystals, the fact that we have phase transitions between gas and liquid. All the basic fundamental properties of matter can be more or less explained by the atomic theory. Now we know we can smash atoms apart, and inside the atoms there are subatomic particles. But then the question is, we now have hundreds of subatomic particles. In fact, when I got my PhD from Berkeley years ago, I had to memorize the names of all these subatomic particles, hundreds, thousands of subatomic particles. And to get a PhD, you have to memorize the names of all of them. Well, today we think that all of them in turn can be summarized by a string. They're nothing but vibrations of a tiny string. And so in the future, I would hope that if you get your PhD from Berkeley, all you would have to do is say string theory, and you would get your PhD. So the atom is no longer the smallest constituent. We really don't know what is the smallest object, but the leading theory right now is that it's a vibrating string. Then we have neurons. There are 100 billion neurons inside your brain, as many neurons as there are stars in the Milky Way galaxy. And a neuron is more or less like a transistor. It's a relay that allows you to send signals from one part of the brain to another part of the brain and control that process. So the neuron is like a gate, and that's what a transistor is. A transistor is a gate that controls the flow of electricity. You can shut it off or turn it on. If you turn it on, you get symbolically the number 1. If you shut off electricity, you symbolically get the number 0. That's binary, and that is how the brain calculates. The brain uses the fact that it can shut off electricity or turn it on, and that allows the brain to calculate. And so the brain would be, in some sense, the smallest unit of brain activity, the size of a cell. Okay, well, let's move right along to the next listener phone call.
Yes, my name is Carl, calling from Pottstown, Pennsylvania, listening on 8:30 a.m. And I was wondering if you could help me with an answer to this question. What happens to an object when it approaches the speed of light? Does it simply stop accelerating?
Well, it turns out that you cannot reach the speed of light. However, with our atom smashers, we can go to 99.99999% the speed of light. So as you get closer and closer to the speed of light, it requires more and more energy to keep you going, but you never break the light barrier. Your mass gets heavier, time begins to slow down, and your spatial dimension begins to get compressed. So if you were to hypothetically hit the speed of light, which you cannot do, you would be infinitely flat, infinitely heavy, and time would stop. Now, obviously, these three things cannot happen. So you cannot reach the speed of light. However, with our atom smashers, we can accelerate protons to very close to the speed of light, but you can never break the light barrier. We've tried many times. Many times there's been an announcement that somebody broke the light barrier, but each time we find that, nope, you cannot. Now, there was an announcement about 5 years ago from Geneva, Switzerland, where some physicists said that particles went faster than the speed of light from Geneva, Switzerland to a detector in Italy. That made headlines because these were reputable physicists saying that maybe Einstein was wrong. Well, of course, physicists redid the data, and they found that it was miscalibrated. It turns out the GPS system used to calculate the distance between Switzerland to Italy was miscalibrated. Human error. Now, the irony is the GPS system itself is using Einstein's theory of relativity. So in other words, Einstein gets the last laugh. Sorry about that. After the break, we'll talk about speculative schemes to go faster than the speed of light. But at the present time, for us Earthlings, we cannot break the light barrier. Okay, well, let's move right on to the next listener phone call.
Deborah, I just wanted to know why hasn't the hydrogen cell taken off for supplemental fuel with cars? I've seen plans on the internet for building your own. I didn't know if they were safe, but I know that even the battery, when it's charging itself, produces a small amount of hydrogen anyway that normally is a hazard, but could be used as a clean-burning supplemental fuel.
Okay, well, you ask a very important question. Some people think that we're going to be entering the age of hydrogen, that will have hydrogen fuel cells, that will have hydrogen in our cars, that will use fusion from the sun, which is based on hydrogen. So what's the problem? Well, the problem is basically cost. Yes, it is possible to make a fuel cell car. Toyota has one, for example. It's a great car. It's all electric, and the waste product from the exhaust tail is pure water. In fact, in principle, you can drink it. Think about that, drinking the waste from a car. That's impossible with a standard car, but you can do that with a hydrogen fuel cell car. So let's break it down. First of all, some people say hydrogen is volatile. It will explode. Therefore, that's a problem. Yes, that's a problem, but look at cars today. Cars today also explode, and we live with that fact that cars explode every day. We just live with it because cars are so convenient. Second of all, you would have to have a hydrogen refueling station every few blocks. And many people say that's not possible. Well, take a look at fossil fuel cars. We have gasoline pumps every few blocks. So in other words, hydrogen fuel cells, the criticisms against hydrogen fuel cells are identical to the criticisms used against gasoline-fired cars. So why don't we have fuel cell cars? Because of, well, cost. They have to be mass-produced. We have to get the infrastructure ready for it. And remember, the infrastructure for gasoline-fired cars took decades to get the basic infrastructure for hydrogen, for gasoline-fired cars. And fuel cell cars, well, the infrastructure does not even exist yet at the present time. So how do these fuel cell engines work? How come they're so expensive? Well, in high school, you probably remember that you can get a tank of water and put 2 electrodes in that water, and one electrode becomes the anode, one electrode becomes the cathode. Hydrogen accumulates in one electrode, and oxygen accumulates in the other. That proves that water is H2O. That is, water is made out of 2 atoms of hydrogen and 1 atom of oxygen. That's called electrolysis. You can also do the reverse process. When hydrogen and oxygen combine, it releases energy. In fact, I still remember, I'll never forget this, I was in junior high school where my science teacher demonstrated this thing. And then, well, like an idiot, he got a match. And because there was hydrogen and oxygen, a match would ignite it. Well, what happened was it exploded. One person in the classroom got sent to the hospital. I'm not kidding. This actually happened when I was around 7th grade. One of the kids in that classroom was actually sent to the hospital because the glass container exploded. Well, of course, we don't want to have that in a car. We want to have that done safely in a hydrogen fuel cell. And again, they exist. They're just very expensive. But one day we may have hydrogen refueling stations on every few blocks. Okay, well, I'm afraid that's it for Science Fantastic. Good day.